All right, everybody. We talked about solubility curves and what they mean and what they do, and what information we can gather from them. We talked about the idea of saturation, a saturated solution, and what that is, and that's really the focus of this, unsaturation and supersaturated solutions. Now, what I want to do is take a look at Table G, which is the New York State Regents exam reference table that has to deal with solubility curves. And if we take a look at it really quickly and just take a couple of important points off of it, first of all, it's a very busy looking curve, okay? And that's the first thing you want to take out of this is that it's very, very busy looking, okay? And it's got quite a bit of different compounds on it, okay? And again, just to remember a couple things about this is that we have temperature on the x-axis, bottom axis here, and we have solute on the solute on the side. Okay, and remember, we're only looking at 100 grams of water here. However, this graph can be proportioned to more solvent or less solvent. Okay, so what you really should do is use the graph as a focus and then make your calculations accordingly to that, or proportional. A couple of things to note is that you have very soluble materials higher on the chart, right? So if you're at 10 Celsius, and you go up, you'll see you're hitting these lines. You are more soluble the higher you are here because more will dissolve at that temperature in comparison to other lines. It's a very busy graph. There's lots of ways that you can make a mistake here by watching how you intersect the lines. There's also several or different compounds here that have very similar names to them, like potassium chloride versus potassium chlorate, okay? Ammonium chloride, sodium chloride. It's easy to, ammonium nitrate, potassium nitrate, and there's also sodium nitrate, and the lines cross at different spots. So you really want to be careful here. Also, there's some estimation issues you could have, right? So 60 here and 70 here, there's no lines here, so you want to make sure you're estimating close enough. There will be a little bit of a give on either side of a gram or so, when you're looking at the temperature or here when you're estimating. Okay, so with Table G basically shows you how much of a particular solute can dissolve in 100 grams of water. Again, when we do this, when we graph, we want to graph two variables and we want to keep one the same. So we're keeping this the same. We're going to graph temperature versus the amount of solute, okay, in grams, okay, and under a range of temperatures. And then these can be thought of, like we said a while back, these can be thought of as saturation lines. So these are the lines of saturation that you would have for each of these compounds at that temperature, at that amount of solute, okay? A few of these, if you notice, you'll see HCl here. We can also notice SO2 here. We can also notice NH3 here. If you take a second to think about that, you'll notice that these do what? Yes, you're right. They actually go down in solubility as the temperature increases, okay? And that is otherwise known as a gas. So these three compounds, HCl, NH3, and SO2, are gases, and you can see as the temperature increases, their solubility actually decreases. All right, and that's going to be important to know going forward to make sure that you notice that these are gases. Okay, and last thing is, please understand that you can adjust this graph for different amounts of solute, dissolved in different amounts of solvent. Use your proportions. Okay, so for example, if you can fit 50 grams in 100 grams of water, okay, and you're saturated, let's just say you have a saturated solution of 50 grams of a solute in 100 grams of water. Well, if you have 200 grams of water and you double the solvent, if you want to stay saturated, you can also double the amount of solute, okay? So 50 can dissolve in 100, and 100 can dissolve in 200, and they're proportional, right? They still are saturated. So it's something important to know here. If also you went down to 50 grams of water, you cut it in half, you would also cut the solute in half. So you got to be really careful. Make sure you're reading carefully on this, okay? And that's the case. All right, so what I want to do is let's do a couple of examples of this to see how we can handle these curves, and we'll take it from there. So if I go to the next, you'll see here some certain questions. What I'm going to do is, I can't write on this PowerPoint the way it is, so what I'm going to do is I'm going to have up Table G here next to us, okay? And then what we can do is then we can then write on this as we go. All right, so take a look at the, if we take a look at this, I'll just move this window over slightly so we can know what we're doing there, and we can see the whole problem. Sorry about this little break here, but we'll figure it out at some point. There we go. Good, right at the edge. All right, so what we'll do is we'll keep track on the side here for the answers to these, so at least we could write them down. All right, so if you take a look at the first question, it says, how many grams of sodium chloride can dissolve in 100 grams of water at 30 Celsius? What we want to make sure to do is we define how much water we're dealing with. And since that matches the graph here, again, we're matching the graph, that means we can read it directly off the graph and we get our answer. All right, so it says how many grams of it can dissolve in 100 grams of water at H2O at 30 Celsius. When they say how many can dissolve, they're looking at the saturation point. So what we want to do is go down here to 30, lock my eyes on 30, and I'm going to go up until I hit the sodium chloride line. If I go up, I would hit it about right there. Okay. Again, on the line is going to be saturation. So since that's the maximum that could dissolve, and that's what the question's asking, I can estimate that to be about 38 grams. If you said 30, 37, or 39, you'd also be fine. That would be good. All right, and number two, we could say, okay, how many grams of ammonium chloride can dissolve in 200 grams of water at H2O at 65? All right, so they're giving us a temperature. We're going to come over here at 65, just about in the middle, again, estimation. Okay, how many grams of NH4Cl can dissolve? Again, very similar to question number one. But again, this is asking for saturation, right? Can dissolve. So we're going to go up and we're going to try to find our way until we hit the ammonium chloride line. So we're going to have to, sneak through all these other lines. And roughly speaking, it's really right on the 60 line. Okay? Now, something important now. We got to be careful. How much water are we dealing with? Well, in this case, the answer would be 60 grams, right? But that would be if you were in 100 grams of water. Okay? So if it's 60 in 100 grams of water, all right, then in 200 grams of water, we must have 120 grams. So 120 grams would be the answer. Okay? And that would be that. Okay, so number three, let's just say we had 80 grams of sodium nitrate is dissolved in 100 grams of water at 10 Celsius. Okay, so where is that on the graph? So 80 grams of NaO3 is dissolved at 100 grams of water at 10 Celsius. Okay, so then it says, is the solution saturated, unsaturated, supersaturated? Okay, so we're just looking at whether or not where we are on the lines, right? So if you're on the line, we're saturated, above the line, supersaturated, underneath the line, unsaturated. So let's just take a look. So 80 grams at 10. So I'm going to lock my eye here at 10. Okay. Again, I can probably get rid of, all these extra lines here. Give yourself a break. Okay. We can say, okay, we're at 10 Celsius. We're going to stay on that line. We're going to go up, and we're going to go up until we hit 80. And look at that. We are on the line of sodium nitrate. So that would make us saturated. All right. So it would be a saturated solution. All right. And we're getting there. All right, number four, a saturated solution, okay, of KNO3 is made in 100 grams of water at 60 Celsius. Again, I'm loving that 100 grams of water because I don't have to do anything with the graph, so I'm right on that. That's cool. Okay, I'm at 60, so I go over to 60. Again, I'll erase my little scratch marks there. Okay, I go to 60, okay, and it says a saturated solution is made. So if I go up to KNO3, I would be on the line at KNO3. Perfect. Okay. Now, if I look across, I would say that's about 105, right? That would be what I think we should do, right? About 105. Okay, so that's fine. And it says the solution is then cooled to 30. So we're going to cool this thing back to 30 there. We're going to cool this back. And if we cool this back, it's asking you how much should precipitate out. So they're telling you you're going to get crystals. Now, if I take a look at 30, I am going to find that saturation point to be here at about, I'm going to say 48. Okay? Now, you got to think about this for a minute. At 60 Celsius, you could fit 105. But at 30 Celsius, you can only fit 48. So the difference between the two is the amount of crystals. So we're going to take 105 and we're going to subtract 48, and we're going to get about 57 grams of solute. Okay? Now, that means that 57 grams will be crystals. okay? Because you can only fit 48 at low temperatures and 105 at high. All right, so we're all good there. Okay, and number 5, a solution is made with 40 grams. A solution is made at 40 Celsius, so we're going to go here. We'll erase what we got before. Okay, we'll go to 40 Celsius. So 40 Celsius is here. Okay, in 100 grams of water, okay, by dissolving 40 grams of ammonium chloride. So ammonium chloride is this guy right here. So we're going to have to go 40. And it says that 40 is dissolved. So we're going to be right there. So 40 in 40, 40 at 40. Okay, and it says how much more solute is needed to saturate. Well, right now we're unsaturated, right? So this is unsat, right? And we want to know how much it is to get there. Okay, so because we already have 40 in, at 48 you'd be saturated, you need to go up 8, right? So 8 grams more you'd need. Okay, number 6, which compound is least soluble at 40 Celsius? Well, let's say at 40 Celsius here. Let's go here. We'll erase what we need here. Okay, these are just some of the questions you can be asked. Okay, let's go to 40 Celsius. And they want least soluble. Least soluble means the least amount that you can get in a solution. So generally speaking, the lowest line on this entire line of 40 Celsius, the lowest line is right there. And the answer would be SO2. SO2 is the least soluble. The most soluble would be up here at 40, would be up here. Probably Ki would be the highest thing there. Okay, and let's see on so number 7. Okay, number 7, if 200 milliliters of a saturated solution, okay, at 50 Celsius were evaporated to dryness, what would be left in the beaker? And again, that just means that we're going to evaporate all the water and leave the solute behind. So we're in 200 mils of water though, so we're double the graph. So let's just find out what you would get in the graph. It was 100, right? So we'll get rid of this. Okay, again, we'll erase. We'll go to 50 Celsius, okay? We'll go to KClO3, 50 Celsius, and let's just see. Saturated solution means we got to hit the line. So I'm hitting the line here at about, it's a little over 20, so I'm going to say 21. So that's 21 grams in 100. So if it's in 200, then I must also double the 21. So 42 grams of KCl would remain. Okay, so that's it, folks. Those are the first 7 questions here. Again, very similar to the type of questions in your packet, but at least you knowing how to deal with the different types of questions you can ask on Table G. All right, have a great day. We'll see you.